So for number 5, we want to write this quadratic in standard form. Okay? And the tricky part of this one is it's in vertex, and we don't like going from vertex to standard. It just weirds people out a little bit. But I'm telling you right now, it's not a whole lot harder than the last problem. Really, you just have to kind of get off on the right foot, and then you're right back where you were with the last problem. So I'm going to need a little bit more room. This is -2. I believe it was x minus 3. Yep, quantity squared plus 4. Double check, make sure I wrote it down right. Okay, we're good. And what I mean by get off on the right foot is you have to understand how to deal with that exponent. And the way we do that is we just write it out like it was multiplication. X minus 3 quantity squared just means x minus 3 times x minus 3. Notice this plus 4, even though I wrote it wrong, plus 4 is still hanging out here on the very end. Okay? But we have to deal with all of this multiplication first. We had to deal with the exponent first and then the multiplication because these rules still reign supreme. Had to deal with the exponents first. Now we have to deal with the multiplication division stuff. Then we can finally get to this addition subtraction stuff. Okay? So we've gotten the exponent taken care of, and now we're ready to do some multiplication. Just like I told you on the last problem, if you want to take the -2 and distribute it in first, that's fine. Now make sure you only distribute it to these first two. Otherwise, you'll double multiply it. But most people seem more keen on doing the binomial distribution first. So the -2's out front. We have x squared minus 3x minus 3x. I'm starting the second one now. Plus 9 plus 4. Okay? Now, you can see we again have some like terms in the middle. I'm just going to erase them and rewrite them as minus 6x. That's what it would have been, -3x and -3x. Okay? Now, we're ready to do our last distribution because we have to take care of all the multiplication before we can move on to that addition. Well, when I take that -2 and put it into every single piece, we'll finally be able to be in just like one single color. -2x squared, positive 12x, that's me going every piece one at a time, -18. And now that we're finally done with all these multiplications, we are able to drop our parentheses and have our plus 4, giving us our last little set of like terms. -2x squared plus 12x minus 14. This would be standard form. Okay? -2x squared plus 12x minus 14. All right, I'm going to just put a check mark there so I know I'm done with it. Number 6, write the quadratic in vertex form. Okay? So remember, all the way back up at this, we identified all these different go-betweens. We're here in standard, and we want to go to vertex. That's what this problem's asking us to do, and it's what the next couple problems are asking us to do. Okay? So we've got 4v squared minus 16v minus 20. Okay? And we want to go into vertex form. Well, that means we need that big old set of completing the square steps. Thought I had them up there. What those boil down to is we have to know to start out the right way, because it was a big old thing of steps. Okay? We're always going to start from standard form, and that's good because that's where we already are. Today, most of you have already seen me do this problem. I did it in class today. Today, a lot of people kind of were forgetting these little pieces. Most of you had step 4 right, okay? In some semblance, you had step 5 right. A lot of you are pretty good at the factoring, and most of you, almost all of you, knew that last step once we got to it. But it was some of these first steps that were causing problems, okay? So our very first one is we first off have to have a y in there somewhere. Okay? Ours probably should have started with f of x over here. But we know that f of x can be just y. And most of you at this point are used to seeing it over there. And that's fine. We can switch it aside. Okay? And we're on to that very first step. It's kind of a hidden step. And as we want to take that 20 and move it over, we want y plus c on the right-hand side. So we add 20 and we add 20. Guys, this process is going to take some studying tonight. Okay, you're going to have to brush up on it. Okay, now our next step, I guess I should write these in a different color. These are going to be in black for this problem. Y plus C was our first step. Our second step is that we want to make A equal 1. Okay? And to do that, we just use this left side and we GCF a 4, not GCF. We just factor a 4 out, leaving us with V squared minus 4V. And the right side didn't change. Okay? Notice if I was to multiply this 4 back in here, we would get the exact same thing from the other step. We did not change the value of the problem. Okay? For our next step is where things get a little bit tricky. It's where we introduce these blanks. Because inside that parentheses, we want to create a perfect square trinomial. That's where this technique gets its name, called completing the square. We want to complete this perfect square trinomial. And to do that, we hop over in our scratch work and we do this next step. I'm going to write it in black again. This next step is that we want to do B over 2 quantity squared. That's the step that we're using down here. More specifically, that's actually what we're using right here. Now, to do that, we need our B value, which is negative 4 over 2 quantity squared, which is negative 2 quantity squared, which is just 4. That's what goes in our left box, our trinomial box. That's how we complete this perfect square. Now, this is where things get tricky because I don't just automatically write 4 in that other box. You would think I would. What I add to one side, I add to the other. That's correct. But this is not really a 4. It's a fake 4. It's a hidden 4. Okay? What it is it's 4 4s. You multiply these two pieces together, and that tells us the amount of weight you added to that side. So think about it in terms of like lifting weights out in the gym, okay? If I'm going to take, and you would never add 16 pounds to one side, I don't really think, but if I was to add 16 pounds to one side, I have to add 16 pounds to the other. If I had 4-pound weight, and I took 4 of them, 4 4-pound weights, and stacked them on one side, then I've got to stack 16 pounds on the other side, however I do it, to make sure that it's even, okay? So you have to be very careful there. After that, we've got a perfect square trinomial, and I'm going to write this in parentheses because you're going to factor what's in parentheses, okay? Whenever I factor what's in parentheses, you can either do the shortcut, I like the shortcut, or you can use the box method. I'll show you both this time, but after that, I'm just going to use the shortcut. Okay, this would be V, you take the sign in the middle, minus, take the square root of that, 2 quantity squared equals Y plus, now don't let me trip you up here. I'm about to write down 36 because 20 plus 16, those are like terms, is 36. Now, this left side, V minus 2 quantity squared, essentially appeared out of thin air to a lot of you. Okay? But let me prove to you that it did not. Head back over into our scratch work. If we had V squared minus 4V plus 4, if I was going to factor this, I'd look for factors of 4V squared that add to be negative 4V. Well, that's got to be negative 2V and negative 2V. It just has to be. Only one that's going to work. So when I throw this in our box, we have V squared, 4, negative 2V, negative 2V, GCF of V, GCF of negative 2. GCF of V, GCF of negative 2, which is V minus 2 and V minus 2, or V minus 2 quantity squared. That's where this came from right here. Okay? It wasn't magic. I didn't just know it by heart. It's a shortcut. Very last step we need is we have to take this 36 and move it back over to the other side. Okay? Whenever we do that, we have 4 V minus 2 quantity squared. This would be minus 36 and minus 36. It has nothing to attach to, so it just goes out on the end.